we are finishing up lesson 26 today. Last concept, exponential growth and decay. This has absolutely nothing to do with derivatives. Why it's in this lesson, I don't know. But it is, because the rest of the lesson talks about derivatives, and this one is not. This may have been a concept that you probably have talked about, maybe in chemistry, possibly in physics. I'm not quite sure, but this is more of a science concept. The solving is a math, so that's why we're seeing it come up in our lesson here. So in our question today, we're going to be looking at some different exponential equations. Now, with an exponential equation, the variable is in the exponent. So it's not going to say like x squared, it says something like 2 to the x. That's what it means when you have an exponential equation. The ones that we're going to focus on here today about exponential growth and decay, they do see them a lot in math and science, even specifically more in science. You have some sort of bacteria that grows at some sort of rate, or you have this chemical that decays at a certain rate in a question. That's what we're going to be focused on today with an exponential equation. You do not need to write the next bullet down. These are just some different scenarios where we see exponential equations. Anna, would you mind reading that for me, please?
Model the growth rate of bacteria, the voltage of the capacitor, radioactive decay, growth of money in a bank account, and other real-world situations.
Alright, so those are just some different scenarios where this idea of an exponential equation is applied. Like you may have seen questions before, you put money into a bank account, it compounds monthly, it compounds annually. You would need to use some form of exponential equation to help you find out how much money do you now have on the question. In the exponential equations, we are going to use the following equation to help us with all of the setups in our question. So I have a parenthesis t equals a to the 0, e, and then up in the exponent is kt. Okay, so we're going to break each of those down, make sure we're understanding what do those pieces mean in the question. Beginning on the left-hand side of the question, A. Any guess what the letter A might stand for in these questions? So if I'm looking at bacteria, I start with a certain blank, it decays, and now I have a certain blank. What word might start with the letter A that I can fill into those blanks? I start with so much, now I have so much. So what word starts with A that means how much I have? The amount. Okay, so the letter A is the amount. I'm making you think today. So the letter A is the amount. So A, with that parenthesis T, is the amount at a particular time, T. So the question is going to say at 2 o'clock we had 500 grams. So it's going to tell you a certain time. So even on the right-hand side where I see the letter T, that's the time that has been going on in our question. Okay, the second one is going to go straight across the question here. The next one I run into is A to the 0, excuse me, A sub 0. Now over here on the left-hand side of the question, when it said AT, that's the amount at a certain time. What time is it if it says A0? Where are we at in the question if it says A0? I thought I'm hearing it on here. Pardon me? I thought I heard something that starts with an S.
Stop.
Pardon me?
Stops.
Nope, it's not where it stops, it's where it starts. There we go. So A0 is the initial amount, is the time 0. So where does it begin? The T is 0 in the question. So it's going to say at 2 o'clock you now had 800 grams. You began with 400 originally in the question. So the amount that you now have goes in for the AT. The amount you began with is the A0. That's the time 0 on your question. Now, on the right-hand side of the question, the letter E will stay in the problem. We're not going to replace anything for the letter E. That's our natural problem, or the natural kind of logarithm that's connected with the ln. And we'll use that to help us solve here in just a second. Up there in the exponent, there's two different pieces, the letter K and the letter T. Now, we already know what the letter T stands for, and that is what? Time. Okay, so it's the time from where you began to where you're at now. Okay, so if I began at noon and now it's 8 o'clock, 8 hours has passed. That would go in for the T on the question. That's the amount of time that we have. Now, for the letter K that we have on the question, it is going to be a constant that we have to look at for each individual problem. The letter K would always be the first thing that you're going to be attempting to solve in the question. That means you're going to know something about the amount that you now have. You're going to know something about the original amount in the question, and you know how much time has passed in the question. The only thing that you don't know would be the letter K. We'll review how do I solve in a situation like that to figure out the K that is up there on the exponent. Now, the letter K will not be the final answer in the question. But I need this constant, because constant is the same all the way through the question. I need this constant to actually answer the question that has been presented to you. That letter K is giving us the rate that it's growing at or the rate that it's decaying at in our question. Again, it's not the same for every single question. That's why I have to do it every single time in our problem. Now, I'm sorry I should have typed this out for you because it's a longer question, but we're only doing one of them together today. So if you, I'm going to give you a few minutes. If you would please go ahead and copy down this question. I'm sorry. Once we're done with this question, I have 3 in our textbook that I'm going to have you try with the exact same kind of setup, looking for some pieces here. Have you guys done these kind of questions in science before? Do they look familiar at all? No. You have it on the backup side of the slide that I can write on here. So when I'm going to do these exponential questions, David told me in the problem, assume exponential growth, and that clues me that I want to use the equation that I just gave you. A t, the amount after a certain time, equals A sub 0, the amount that I began with, e, and then in the exponent k, t. The k is that rate of growth or the rate of decay. The t is the amount of time that has passed in our question. The first piece, again, that you're always going to solve for is the letter k. That means you can fill something in for the other three variables in our problem. In the question, Alyssa, how much do we have after a certain time has passed in the question?
400.
Read that again. So it says the number present at noon was 400. That's what I started with. And this is after this amount of time. 800. So the 800 is what I'm going to put over here in the question. That's the amount that I have after the 9 hours, or after the 9 hours has passed in the question. Josiah, according to our question, how much bacteria did we begin with on this question?
400.
It is the 400. So we began at noon. That was the 400 that we had in our question. Again, the e is going to stay there. We're never going to replace the letter e. That's going to help us as we're solving here in just a second. We are not replacing the k. That's what we're attempting to solve for. Now, we got to think carefully here. We began at noon, 9 hours later. So, I mean, this one we don't have to think. The book is going to put that as like it's 1 o'clock, now it's 5 o'clock. Well, then 4 hours has passed. Well, this one actually told me 9 hours has passed. So I'm going to write this as 9k. I'm just going to bump the k back instead of putting k9 on our question. Again, step number 1, I need to solve for the k. Amelia, any thoughts on where we're going to begin to get k by itself? Divide by 400. That would be our first step in our question. We're trying to get the k by itself, and the k is attached to the e. So let's get the e by itself. 800 divided by 400 gives us 2. And I have e to the 9k. Now, at this part of the question, we need to remember something that we learned earlier this year, because the part that I'm looking for is up in the exponent and is on the letter e. There is something that I need to insert on both sides of my question that is going to allow me to rotate that 9k out of the exponent. Alyssa, what is that? It is the ln. You're doing the logarithm on both sides of your question. So I'm going to do ln2 equals ln e to the 9k. We're always going to be using that ln, not the log. The log was one that had a base 10. Ln was the natural logarithm that had a base of e on the question. The left side, we're going to go ahead and leave that as ln2. The right side, when we had a logarithm that had an exponent, we were allowed to take that exponent and rotate it down to the front. So we have 9k ln e. Now, that was helpful in the question. On the right side of the problem, there's something that I can get rid of. What can I get rid of on the right-hand side of the question? Testing our memory here. Alyssa?
LNE.
Why can I get rid of ln?
They equal 1.
It does equal 1. Remember, ln is the same thing as log base e. Well, this says log base e to the e. If you guys remember back in advanced math, we talked about something that was called White House problems. The White House problem told you if these two bases match, which they do in the question, they make each other go away. All that you were left with was the exponent. Well, I don't have an exponent sitting there, so what's e to what power? It's understood to be 1 in our question. So that helps us because in our problem it says 9k times ln e. Well, ln e just has a value of 1. Multiplied by 1, it doesn't do anything in our problem. One last step here, Josiah, to get k by itself.
Divide by 9.
You're going to divide by 9. Now, at this point of our question, we are not putting that on our calculator quite yet. If we do it now, we're going to be rounding a little bit, and we want to have the most exact answer for how much do we have left in our question. So I'm going to leave this as ln2 over 9. Okay, everyone with me on step 1 of locating the k in our question. All right, so let's go back to our problem and see what are we actually trying to answer. The question says, find the number of bacteria, so I'm looking for the amount after a certain time. So So I'm looking for what's on the left-hand side of the question. Find the number of bacteria present at noon the next day. So I'm saying the amount, and I'm going to put something in the parentheses in just a second. I'm going to leave that blank for just one moment here. A0. Well, that's the same. How much did we begin with on this question? 400. We have our E, and then there's the constant that we're going to fill in just a second that we located in our problem. Now, we're also going to fill in the letter T. Again, the letter T is the total time that has passed. The question began at noon. It is now noon the next day. And it said in the problem, T was in hours. How many hours have passed between noon today and noon tomorrow? Pardon me? 24. There's 24 hours in a day. So in this parenthesis on the left-hand side, I'm going to put a 24, because that's for the letter T. The amount after a certain time, the amount after 24 hours equals, and then on the right-hand side, our constant, we have ln2 times the time of 24, and I'm going to put that all over 9 up here in our exponent. The original exponent, it says ln2 over 9, or ln2 over 9 times 24, but 24 is 24 over 1, and so I can put those two things in the numerator, and I just put this inside parentheses to show that just the 2 goes with the ln. Alyssa, do you have a question for me?
So is that 24 with the first A? Will that be multiplied by that?
It will not. That's just labeling in the question the amount after 24 hours. If you don't even want to write that there, that's perfectly fine. That's just how the book is setting them up for their solutions. So I did the same as well. It's just the amount for the time that I'm looking for. If you just want to write AC, that's perfectly fine as well on your question. Now, at this point, here's where I'm going to put this onto my calculator, because there's nothing else that I can do by hand. So on your calculator, we're going to start with our 400. So go ahead and hit your 400. If you will hit your E button, that's, I think it's over on the left-hand side, it's above the LN button, so second or the shift with your LN key. It popped up your little caret, so you're up in the exponent. Now, on the exponent, I need us to carefully enter this. That ln2 is inside parentheses. Yes, it popped up in parentheses originally, but that's going to be everything in the numerator. So start with another parenthesis, type in your ln2, close that parenthesis, hit the times 24, close the original parenthesis, divided by 9, and hit enter. If you've entered the question correctly, the amount that should show up on your calculator is 2,539.84. If it doesn't show up, let me see your calculator, and we'll try to figure out what you entered incorrectly on your problem. Okay, so these are like those, how much money do I have? If it's compounding annually, it's compounding monthly. I got to figure out the rate that it's going at, and then I can put it back in to actually answer how much money do I now have in the question. Yes, ma'am? Didn't get that. Okay. Okay, I think I just need one more parenthesis right here. So let's try that. It's not going to let me go up here. 400. Okay, so top of the parenthesis originally, this is for the entire numerator. I want to keep that ln2 inside its own parentheses. So ln2, close that parenthesis. The 24 right next to it. We're done. Let's see. For anything, we just hit the divide by 9. Then close the parenthesis for the full exponent up there. There. Now. Okay. You guys decided to come out? Okay, what we're going to do, everything's fine, how you entered it at the beginning. So we're doing 400, and then our shift E, put up the exponent originally. This parenthesis is referring to the entire exponent. So you start with another parenthesis for your ln2, close that one. The 24 is right next to it, so I'm going to put another parenthesis. You have the times. That's okay. You have the times there as well. Close that one. Then divided by 9. You're done with the whole exponent. Close the parenthesis. Now hit enter. You have the parenthesis ending back here. And then this divided by 9 is dividing everything by 9 and not just the exponent by 9. Okay? Did you get that to work, Alyssa, on your calculator, Anna? You good? All right. So your questions today that I would like you to work on, they're on the same page as our problems last night. I think that was page 150. It's the first 3 problems from 1 through 3. They're the exact same setup that we have for these exponential questions. You guys got about 10, 15 minutes here. So is it page 150? Is that right? Yeah. So page 150, questions 1 through 3. They're all of these exponential setup questions.